In this video, we're going to look at integrating slightly more tricky exponential functions. So just to recap of what we've done so far, we know if we integrate e to the x with respect to x, you get e to the x plus c. And also, and this is more like what we're going to be looking at today, if you integrate f dash of x upon e to the f of x, you get e to the f of x plus c. So we're really going to be looking at this one, and we're going to be looking for the presence of the exponential function and its derivative. So they're the ones we want to get onto. Just to be easy one to get us started. In one like this, and one other thing for us to add in up here would be if you integrate e to the mx with respect to x, you get 1 over m e to the mx plus c. So here it's just e to the 3x, so it's going to be your integral is going to be 1 over 3 e to the 3x plus c, your constant of integration. Okay, in this one, what we want to do is just test this thing out. So what we're going to do is just differentiate e to the x squared just to see what you get. And if you differentiate that, you get your same e to the same power, x squared, and differentiate the power, you get 2x. So we've shown if you differentiate e to the x squared, you get 2x e to the x squared. That means if you integrate 2x e to the x squared, you will just get e to the x squared plus your constant of integration c. Okay, example 3 looks much harder, so we're going to just differentiate the e to the cos x and see what we get when you do that. So the power is going to be e to the cos x still, and just differentiate the power. If you differentiate cos, you get minus sine. So it's not quite what we wanted. So therefore, if you differentiate minus e to the cos x, differentiate that with respect to x, you will get what you want. You'll get sine x e to the cos x. So we've differentiated minus e to the cos x, and you get sine x e to the cos x. That means if you integrate sine x e to the cos x, you will get minus e to the cos x, and then plus your constant of integration. Okay, for this one, I'm going to just do this using the very simple method. I'm going to just say that's the same as 10 times, and if you integrate e to the 5x, you'll get 1/5 e to the 5x and plus your c, and then just 10 times 1/5 would just be 2. So e to the 5x plus c. Very easy. Okay, example 5. Again, I'm just going to differentiate e to the x squared plus 1 just to see what I get. So I'm going to get e to the x squared plus 1 still, and differentiate the x squared plus 1, you'll get 2x. So without doing any extra work down here, I'm just going to jump to the answer. I can see what I've done gives me something which is 2 times too big. So that's going to be, my answer is going to be a half of e to the x squared plus 1, and then plus my constant of integration. Okay, question 6, we've got 2 bits to this one. I've got to integrate my 4x e to the x squared, and I've also got to integrate 1. Integrating 1 is dead easy. Integrate 1, you just get x. I'm just going to look at integrating or differentiating the x squared, e to the x squared, to see what I get. If I differentiate that, I'm going to get 2x e to the x squared. So that means that's not as big as what I wanted. I wanted it to be 4x e to the x squared. So if I integrate this, I'm going to get 2 e to the x squared, then plus x, and that's between 1 and 0. So putting in 1 into this, you're going to have 2 times e to the power of 1 plus 1. And putting in 0 into this, you're going to have 2 times e to the power of 0. E to the power of 0 is 1. 2 times 1 is just 2. And put 0 into the x, you just get 0. So that's what you have. And if you tally that up, that's the exact answer is 2e minus 1. Okay, a couple of tricky ones left for us here. First thing I want to do in example 7, it's a bit of a mess, so I'm going to just change it to be an integral of x upon e to the minus x squared. Once I've got it in that form, then, forgot my dx, once I've got it in that form, I can differentiate e to the minus x squared and see what I get. Hopefully it gets me on the right track. So if I differentiate that, my power is going to be the same, e to the minus x squared. And differentiate the minus x squared, you'll have minus 2x. Now, not quite what I wanted. I'm going to differentiate minus a half upon e to the minus x squared then. And if I differentiate that, you can see it will give me what I want, x times e to the minus x squared. So that means if I differentiate this to give me x e to the minus x squared, if I integrate x e to the minus x squared, it'll give me a minus a half e to the minus x squared, and then plus my constant of integration, remember. Just because I wrote it this way in the question, I'd probably write it back that way. So that's going to be minus 1 on the top and 2 e to the x squared on the bottom line, and then plus my constant of integration. Okay, last example, I'm going to again differentiate e to the minus x cubed, it is in this case. And if I do that, what I will get will be e to the minus x cubed again. Differentiate the minus x cubed, differentiate the power, you'll have minus 3 x squared. So it's almost what we want. I don't have to write that out again, but you can see it's the same. It's almost the same, it's just negative. So I need to just change the sign of this thing. So it's just going to be equal to minus e to the minus x cubed, and then remember your constant of integration. Okay, you're now ready to do the Understanding Pure Mathematics book, exercise 19a.